Hello and welcome back to the series. In episode 2, we move from theory to our first hands-on session with ML.NET, following up on our goal to predict if any goals will be scored in the first half of Premier League matches. This video covers all the essential setup steps. First, we set up Visual Studio for ML.NET project and install the necessary ML.NET packages. Then we load and prepare our football data within the C# environment, building our first machine learning pipeline for binary classification. At the end, we train and evaluate our initial model to see how it performs. Get ready to write some code and see ML.NET in action. Don't forget to like and subscribe for the rest of the series. In Visual Studio, create a new project of type console application. Let us name it Machine Learning with ML.NET. ML.NET is not part of the standard .NET Framework installation. It's a separate library, which means we need to install it as a NuGet package in our project. As you can read here, ML.NET is a powerful library. Here are the key features. We will just use the first feature, classification or categorization. Under dependencies, then packages, we see that ML.NET has been installed. Once we have that installed, we move on to the core steps. First of all, we create a new class of name football prediction, which will contain our logic for the machine learning pipeline. The first step in the pipeline is to load the data. Our data is a CSV file. For that, we create a new folder of name data. Before we do that, let us check the raw data and the processed data files once more. Here are the columns of the original file. And here is the generated file in the format we need. Let us compare some rows for correctness. The odds were correct, and the goals, we see that 0 plus 2 is 2, 2 plus 0 is 2, and so on. Now let us add the file, and I would make some renaming. So instead of over 2.5 goals, I rename it in over 2 underscore 5, and then under 2 underscore 5. The column first half goals will be HT goals, so halftime goals. Now we add a new folder named models. Within this folder, we define our first C# class for match data, so named match data, which represents the input data columns from our CSV file. The column HT goals, which contains a float number representing the total goals scored, is naturally suited for a regression problem, where the goal would be to predict the exact number of goals. However, for a more practical application, I will focus on a binary classification problem, i.e., predicting simply if any goals will be scored. Therefore, we must transform this numerical column into a Boolean label that is true if ht goals is greater than 0 and false otherwise, making it perfectly suited for classification trainers. I copy-paste 4 columns from match data to match classification data and define the new column, the classification label, which is ht goes above 0. Now back to the class football prediction, where we want to define our prediction pipeline. We start by adding a new method called train classification models. Here, during the implementation, you will notice something special. Usually, we write the code and then write comments about the code which clears what and why. But here, I start with the comments before I write the code and let Copilot try to understand the comment and predicts what I want to try to write, which I call it comment-driven development. I wrote an article about that and it is available on Amazon Kindle. If you are interested about that, you could find the link in the description of this video. Back to the code. Here we defined our ML context, creating a new one. Then we load our data from the file in the folder data. The method we use to load data from the CSV file, named load from text file, takes in the first parameter the path of the data, then a separator char, which in our case is the comma. Then if the file has a header, which is true in our case. The loaded data will be of type iDataView. The loaded iDataView is internally a list of match data where HT goals is the exact number of goals scored in the first half, which would or could be used to solve a regression problem. But as you now know, our problem is a classification problem. We just want to predict if any goals would be scored in the first half. So the task now is to convert from match data to much classification data. And the, the introduced the new column HT goals above 0 is simply true when HT goals greater than 0. Now we create a new data view, this time not from the text file, but from our list of classification data. Now our data is ready to be loaded in machine learning pipelines. The core of building an ML.NET pipeline is selecting the appropriate trainer. Let us start with SGD calibrated trainer. SGD is stochastic gradient descent, which is a linear classification model. The input of any training pipeline in machine learning is so-called feature set or features. In our case, our features are the first four columns in the CSV file. The fifth column, it's the label. So it does not belong to the features. This is the label we want to predict. And as you see here in Visual Studio, the Copilot suggests a pipeline consisting of just two features. That could you do? It will work. However, one important thing you should know. The features define what the model can possibly learn. The more relevant information we encode in the features, or say the more features we have, the better the model will perform. So I will include all the features I already have. We encode the teams because they are labels that represent unique but non-mathematical entities. And we need to give the model a way to assign a unique independent value, or say a weight, to each one without creating false numerical relationships. The odds being true numerical quantities can be used directly. Here we map our feature set to a one input column of name features, which is the default in machine learning. The next suggested step in building the pipeline is to normalize the features and finally to set the desired trainer. The SGD trainer, like other trainers, can be controlled through its parameters. And as we work with the default namings, we could omit the label and the feature set. I would skip the step about normalizing the features for now. I will come back to it during the optimization of our pipeline in the next videos. One last word about the chosen SGD trainer. Here is the documentation as documented in ML.NET. Before we train and evaluate our pipeline, let us quickly check what Copilot could say about this pipeline. Instead of opening the chat window and write my questions there is another practical way. You select the code you want to be explained in the editor, then right-click, choose Ask Copilot, and use the command explain. And here is the explanation. Let us open it in the chat window. If you like, you could stop the video and take your time reading it. Here is the commented normalization step. You can already read the purpose of it. And here the explanation of calibrated probability. Let us ask Copilot to generate a model for that we can use it later in the evaluation. Here the class has been generated. I will copy paste it as a model in my models folder. In simple words, without the probability or the calibrated probability, you just get true or false, which is our classifications, but you cannot say if this is 100% true or 70% true or something like that. But with a probability, you can evaluate how strong a true is. Now let us add this as a model to our models folder, and as said, we will use it later by evaluating the model. Now our pipeline is ready to be trained. We just need to decide on which data we want to train it. If we use the whole data for training, then we don't have any data left for testing. So we have two options. Either we split the data manually, so we make two CSV files out from the original CSV file, or we let .NET or machine learning.NET split the file at runtime. Let us split by 0.3, which means the pipeline will be trained on 70% of data, and we could use left 30% for testing. Lastly, to train the pipeline, we just call the method fit. So we fit the pipeline on the train set of the split data. And the result of the fit method is our machine learning model. We proceed to evaluate the model. First, we call the method transform, passing the test set or the test data. And the result of this call is a special type of data view. This special data view is called predictions data view, which contains all the original columns from our test set, plus the new columns generated by the model's pipeline itself. Now we use the evaluate method, which takes the predictions data view and compares the model's generated columns, like the predicted label and the probability, against the true label column. The result of the evaluate method is a metrics object that quantifies the model's performance by comparing the predicted values against the true labels in the test set. This object contains all the standard evaluation measures we need, such as accuracy, AUC, and F1 score. What is accuracy? Let us assume the accuracy of our model is 90%. This means that the model correctly predicts 90% of matches. AUC and F1 help ensure that the model isn't just guessing the majority class. AUC ranges from 0 to 1. If AUC is 0.5, the model performs no better than random guessing. If AUC is 1, means perfect discrimination. It correctly separates all positives and negatives. If it is less than 0.5, it means the model performs worse than random. Before we move on, I want to clarify that I will not be diving into the detailed explanation of what precision and recall are or how the F1 score balances them. That deep dive into the meaning and interpretation will be the focus of the next videos in this series. For now, let us keep our focus on the ML.NET pipeline, our first pipeline, and let us give it a try. We open the program CS and create a new instance of our football prediction class. Now run the program in Visual Studio. So we have an error that the CSV file could not be found. Right click on the file and in the properties we choose that the file should be copied to the output. Copy always or copy if new. Okay, load column attribute. Okay, yes, I forgot to add these attributes to our data model, and now it works. The metrics seems to be good, yes, but be careful. This might be misleading. How? Well, it depends on the data you have or in the use case you are working on. In my case, I analyzed the data and found out that 98%, no, that 98 matches have no goals. Means that 74% of matches have at least one goal. Now with that, let us assume that someone is betting that in every match in the season, at least one goal will be scored. Yes, he misses the no goals matches, but the accuracy he gets, it's about 74%, which is better than our accuracy from this model. So what I want to say is that accuracy is not everything. We will talk more and more about that in the next videos with different algorithms and different evaluations. For now, think about that and I will see you in the next video.